Hi everybody, Ms. Butler here. I'm going to talk to you today about a CER, that's Claim Evidence Reasoning paragraph about bonding. You will have to write one of these paragraphs on your interim for this unit, so hopefully you find this video helpful and you really understand what your teachers are looking for your claim, your evidence, and your reasoning. Before we get started, hopefully you have learned naming. So I have these chemical formulas and chemical names. They are all covalent or molecular. And so what I would like you to do is pause the video and you are going to write the chemical name for the first three and the chemical formula for those last two. So pause the video. I want you to try them. I will put the answers up in 3, 2, 1. So hopefully you remember the kind of formula we use, prefix name, "-ide, and we drop the ending and add "ide" to that last one. So I got triphosphorus dioxide, nitrogen dioxide, dinitrogen pentoxide, and sulfur pentafluoride is SF5, and then carbon monoxide is CO, capital C, capital O. So when we give you a CER, Claim Evidence Reasoning Conclusion paragraph, you're writing a paragraph to answer the question, is this chemical ionic or covalent? And so you will need two pieces of evidence. The first piece of evidence is going to have to do with with the elements and if they are metals or nonmetals bonding together. So just a friendly reminder, we have that metalloid staircase. That's the guy in kind of pinkish above me. Everything on the left side, all of those purple elements are metals, and then everything above the stairs, those green ones and hydrogen, are nonmetals. So if we have a metal, a purple one, with a nonmetal, a green one, it is evidence that it is an ionic bond. If we have two nonmetals, two green ones, and then don't forget hydrogen up there, two green ones together, that's going to be evidence for covalent bonding. The other piece of evidence we're going to look at is electronegativity differences. So this is where we look at the electronegativity of the first element, the electronegativity of the second element, and we subtract them. And then if it's negative, make it positive, so the absolute value. But based off the difference, so based off the answer when we subtract those two numbers, we can tell the bond type. So remember, electronegativity is the atom's ability to attract shared electrons. So if there is a small difference in the electronegativity, I subtract the two numbers and it's between 0 and 0.4. That means the atoms have very similar electronegativity values. One is not necessarily better than the other at pulling those shared electrons. So we call it nonpolar covalent, which means they are sharing their electrons relatively equally between the two elements. If the difference, when I subtract the two numbers for the electronegativity, is between 0.5 and 1.6, that is polar covalent. So we could think of it as a partial transfer, or we could think of it as these two elements are sharing their electrons, but unequally. One atom is taking more of the electrons or pulling them towards itself more. And then finally, if we have a big difference, so we subtract those two numbers and it's 1.7 or larger, that means these elements are probably not sharing at all. One atom wants the electrons so bad, he's like, gimme, and he takes those electrons because he's way more electronegative than the other element, and so there's a full transfer of electrons. So we have three types: ionic, polar covalent, and nonpolar covalent. So you're saying, Ms. Butler, how do I know what the electronegativity values are? You want me to subtract these two numbers? Well, here's the periodic table we use in class. If you printed out a different one, you should go to Canvas and print this one out. It should be towards the top of this covalent bonding unit module. And so you can print out this copy because you will want this version of the periodic table. So here's an example element symbol. It's got your typical stuff, right? Atomic number, name, symbol. But look, the electronegativity value is in the bottom left-hand corner. So if I have carbon bonded with oxygen, carbon is 2.5, oxygen is 3.5. I'm going to subtract 3.5 minus 2.5. That is going to be the difference in the electronegativity. 3.5 minus 2.5 is 1. So the electronegativity difference in a carbon and oxygen bond is 1. So hopefully that makes sense of where to find those numbers. They are the bottom left-hand corner, and you can print this periodic table out if you do not have one. So you did see this in another video, but just to remind you, so covalent is sharing. Nonpolar covalent means the atoms are sharing equally, so two atoms that have the same electronegativity or a very small difference in electronegativity. Whereas polar covalent is two elements that are still sharing their electrons, but not equally. One is more electronegative and it's pulling those electrons towards itself. And so when that happens, it's pulling the electrons towards itself in this bond, giving it a partial negative, and this one will be partially positive because the electrons in this chemical bond are spending more time over here towards the fluorine than they are towards the hydrogen. Okay. So we're going to practice our first CER paragraph, claim, evidence, and reasoning, and we will have two pieces of evidence and two reasoning. So really this is like a CER paragraph, okay? Couple of things to note. Some of you are very creative, very good writers. That is awesome. You are a better person than I am. In science, we want to get straight to the point. We want to state our answer. We want to state the facts. We want to state why they're important, and we get out. So please, I don't need a question. I don't need a quote. Albert Einstein once said that BCl3 is... No, I don't care what Albert said. I care what you say. Answer the question, give me the facts, and explain why they're important, and then you are done. So these should be pretty short and sweet. I'm also, as you can probably tell, not the best writer, so I find that graphic organizers like this help me. And then what I do is I just turn this graphic organizer into a paragraph. So it's going to be my claim, and then I'll say evidence 1, reasoning 1, evidence 2, reasoning 2 in order. I don't add anything extra in between. I keep it short and sweet, but kind of outlining in a graphic organizer like this helps me, and then I can turn it into a paragraph. So this whole paragraph is going to be to answer this question. What type of bond will occur in BCl3? That's a L for chlorine. So BCl3. So my claim is to answer the question. One sentence, answer the question. What type of bond? BCl3 is a molecular compound, or I could say BCl3 will have covalent bonds. Okay? Answer the question. So your choice is ionic or covalent. That's it. Okay, so BCl3 has covalent bonds, or you can say BCl3 is a molecular compound because those are synonyms. Molecular compound means it has covalent bonds. Okay, let's get to the evidence. Evidence is facts. It can either be numbers or it can be statements that are true. So I am just going to state the facts that I know from the periodic table. If I look at my periodic table, boron is a nonmetal, it's above the staircase. Chlorine is a nonmetal, it's above the staircase. So that's like one sentence. Boron is a nonmetal and chlorine is a nonmetal. Great. Be specific as well. Tell me those element names. Don't just say they're both nonmetals. Be specific. Boron is a nonmetal. Chlorine is a nonmetal. Okay, the reasoning. So this is like in English, this is where you like pull the quote. You know, like you read in your book. You do. Here, I got a book. This is my life. Okay, this was me as a student. I'm reading my book and I'm supposed to write some sort of paragraph. So I do this, right? Quote, put it in my paragraph. Okay, so I have a quote, but your English teacher always says, don't just put the quote, you have to say why it's important. I'm sorry, I'm going to do the same thing to you. Don't just tell me a fact, tell me why. Why does this fact prove that it's covalent? So here's where we say, nonmetals share valence electrons in order for the atoms to all have a complete octet. So boron's going to give some to share, chlorine's going to give some to share, and they're going to be shared between them so that both elements have a complete octet. So this is proving why two nonmetals would be covalent, because they are going to share so they both have a full octet. All right, moving on to evidence 2. So we have claim, evidence 1, reasoning 1. Now we start with a new piece of evidence, same paragraph, just a new sentence. Remember, evidence is just statements or facts. So I'm going to look on my periodic table. I'm going to just list the electronegativities. Boron has an electronegativity of 2. Chlorine has an electronegativity of 3. Okay, now I explain why these numbers are useful in telling me it's covalent. The difference, remember, we're doing subtraction. So the difference in electronegativities is 1. I showed the math kind of in parentheses. You could do it off to the side. But I should see the math somewhere either within the sentence or off to the side, and your answer is part of the reasoning. So when I subtract, the difference in electronegativities is 1. This means that This means that boron and chlorine share electrons unequally, right? One is bigger than 0.4 but less than 1.7, so it's that middle difference level, which means it's a polar covalent bond. So I'm saying that they share because of this answer of 1, and they share unequally, and I'm showing that I know that that means it's polar covalent. Okay, so I have my outline. Now I can put it in a paragraph. I'm literally just going to use complete sentences and say BCl3 is a molecular compound, boron is a nonmetal, and chlorine is a nonmetal. Nonmetals share valence electrons in order for all atoms to have a complete octet. Boron has an electronegativity of 2.0, and chlorine has an electronegativity of 3.0. The difference in electronegativities is 1. This means that boron and chlorine share electrons unequally and is a polar covalent bond. Done. End paragraph. No fluff, no fireworks. Get in, get out, done. Depending on if you break things like this up into 1 or 2 sentences, or this guy, right? These guys could be 1 or 2 sentences depending on how freely you use the commas. But really it should be somewhere between, I would say, 5 and 7 sentences, again, depending on if you like long sentences or shorter sentences. But that's it. That easy. CER. Okay, this one should be typed out in your notes for you. This one says, what type of bond will occur in CaO? The reason I typed it out for you is because CaO is an ionic compound, and this whole unit is about covalent bonding, but I wanted you to see kind of the opposite, right? Chances are on your covalent bonding interim quiz, hint, hint, you're going to have one that's a covalent bonding. So your claim will be that it's covalent or it's molecular because this whole unit is covalent. But I wanted you to see what an ionic paragraph would look like. So here's the outline. CaO is an ionic compound. Calcium is a metal. Oxygen is a nonmetal. Metals give electrons and form a positively charged ion. Nonmetals take electrons and form a negatively charged ion. I actually read in one of the discussion posts a really good idea. How do I know that the one that's taking forms negative? Well, electrons are negative, but think of it this way. The nonmetal feels like it's in debt to somebody because it's taking, and that's kind of a negative feeling, like when you feel like you owe somebody something. I thought that was such a clever idea. So metals give electrons, form positive charge. Nonmetals take that electron and form a negative charge. Positive and negative ions attract to form the ionic bond. So I'm explaining why it's important that a metal gives and a nonmetal takes. Okay, evidence 2. Calcium has an electronegativity of 1. Oxygen has an electronegativity of 3.5. I get those from the periodic table. I'm just listing the facts. Now we explain why it's important. The difference in electronegativities is 2.5, so big minus small gives me 2.5. This is a large difference in electronegativity, bigger than that 1.7 threshold. This means that there is a complete transfer of electrons, which is an ionic bond. Okay, so here's an example for you to just kind of refer to of if the claim is ionic versus the claim being covalent. Okay, here's what we're going to do. What type of bond will occur in CO2? I want you to fill out your notes with the claim, evidence 1, reasoning 1, evidence 2, reasoning 2. Use the first example as a guide to help you. And then in this ed puzzle, you will have a question that pops up where you actually turn your outline into a paragraph. So you're going to type your paragraph into the ed puzzle. Once you're done typing, I am going to show you the answer. I know it's coming after, but I want to see what your first attempt at a paragraph looks like. But then you'll be allowed to immediately kind of check your outline and your paragraph to make sure that you didn't miss any of the facts. Okay, so pause the video. This is going to take a couple minutes. You're going to make the outline, claim, evidence, reasoning on your Cornell notes page, and then you're going to put it together as a paragraph, CERER. So put it all together in the ed puzzle as in paragraph form, complete sentences, and then you can check once you are done. Here's the answers coming. 3, 2, 1. Okay, hopefully that you found that it was covalent, and you can either say it's a molecular compound or CO2 is covalent or has covalent bonds. Either are fine. Carbon is a nonmetal. Oxygen is a nonmetal. Nonmetals share valence electrons in order for all the atoms to have a complete octet. Evidence 2, hopefully you listed that carbon has an electronegativity of 2.5, oxygen 3.5. I find the difference. So 3.5 minus 2.5 gave me 1. This means that carbon and oxygen share electrons unequally because it's bigger than 0.4 but less than 1.7, so that's polar covalent. One thing to note, I know that there are 2 oxygens in the formula. That does not make a difference for the math. You're just figuring out one bond. So you're just going to figure out one oxygen bonded to one carbon. So that makes the math a lot easier. Just look at the elements and subtract the electronegativities. Don't worry about how there are 2 in the Lewis structure. Okay, hopefully that gives you a lot of good ideas of how to write a CER conclusion paragraph. You will see one of these on the interim, and we'll do some practice as well leading up to the interim so you feel prepared. Awesome job, everybody.